Welcome to Academy. In this three-part series, I'm going to prove all the trigonometric identities in one full sweep. Here we go. I've drawn a triangle here with sides A and B and hypotenuse C. Our first identity which I'm going to list out is the father of all trigonometric identities according to me is the Pythagoras Theorem. That is, if I have a triangle with sides A and B and hypotenuse C, Pythagoras Theorem is A square plus B square equals C square. Let's start with the Pythagoras Theorem. Now, I'm going to use the distance formula which is derived from this Pythagoras Theorem obviously, and I'm going to use the distance formula extensively in my next step in the derivation of the trigonometric identities. So let me list out the distance formula also for the sake of completion. Okay, let me describe what is distance formula. If you have a point A with coordinates x1, y1 and a point B with the coordinate x2, y2, the distance d between A and B is given by the following formula. D square equals x2 minus x1 the whole square plus y2 minus y1 the whole square. Next, we have already proved quite a few trigonometric identities in our earlier videos, right? And the mother of all identities is cos square x plus sin square x equals 1. The another variation is cos square theta plus sin square theta equals 1. This is the mother of all identities. Actually, all the trigonometric identities can be derived from the Pythagoras theorem, which is the father of all identities, and the mother of all identities, which is cos square theta plus sin square theta equals 1. Only these two are enough to derive all the trigonometric identities from first principles. So let me list the mother of all trigonometric identities. Okay, we have also proved one or two other identities such as cos of minus theta is cos theta and sin of minus theta is minus sin theta. Okay, here we are getting into the derivations proper. Next, I am going to prove the complementary angle formula, that is cos of pi by 2 minus theta and sin pi by 2 minus theta. And once we do that, I am going to get into the law of cosines, and using the law of cosines and the complementary angle formula, all other trigonometric identities will follow. Actually, all the trigonometric identities, whether it is law of cosines or the complementary angle formula, they all follow from the father and mother identities, that is Pythagoras theorem and cos square theta plus sin square theta equals 1. Let's get going. Now, I have a triangle here ABC with sides A, B and C. A and B are the sides and C is the hypotenuse. If I mark, let's say, this angle as theta, this is the complementary angle and this will be pi by 2 minus theta from the basic property of a right angle triangle. Okay, now what is cos theta? Let me write down cos theta. Cos theta would be the adjacent side divided by hypotenuse, that is B divided by C, correct? Next, what is cos pi by 2 minus theta? Cos pi by 2 minus theta would be adjacent side divided by hypotenuse, that is A divided by C, correct? Let me call this set of equations as equation number 1. Next, sin theta. Sin theta would be opposite side by hypotenuse, that is A divided by C. And sin pi by 2 minus theta is opposite side by hypotenuse, that is B divided by C. Let's look at the equation 1 and 2. You have cos theta equals B by C. Similarly, sin pi by 2 minus theta equals B by C, that is these two are equal. Similarly, sin theta is A by C. Cos pi by 2 minus theta is also A by C. So, these two are equal. Therefore, from 1 and 2, what we can write? Cos pi by 2 minus theta is sin theta, and sin pi by 2 minus theta is cos theta. Very simple, isn't it? So we have the next set of identities, that is the complementary angle formulas. Cos pi by 2 minus theta is sin theta, sin pi by 2 minus theta is cos theta. Okay, so this is all I require to prove all the trigonometric identities. This is the part 1 of the 3-part series on trigonometric identities. Thanks for watching. My next video will be part 2 of the 3-part series on trigonometric identities, and that will be proving the cosine formula, that is the law of cosines. And the law of cosines will be used to prove the further identities. And as always, it's been a pleasure, and I would love to have you back with Academy. Thank you.